Hi there, 7th graders. Welcome to lesson 7-8, the lesson that has taken me the longest of all. This is the 4th take of this lesson. I know, I'm trying to get it short and sweet, but it's really tricky to do that. So here we go. Hopefully this is the final take for me. In section 7-7, you factored polynomials in the form of ax squared plus bx plus c. I know that on your sheet it only said x squared plus bx plus c because every single time a was 1. And if a is 1, you don't have to write it there, right? Well, today you're going to factor polynomials in that same form, except the x squared term is going to have a number other than 1 in front of it. And there's kind of two scenarios that will take place. In the first scenario, you're actually going to be able to factor out the a so that they're just like lesson 7-7. Scenario 2, I'm going to show you another method beside the factor sum chart that doesn't quite work for this one that'll allow you to solve it when a isn't 1. So, the first thing that you should always do when you see a trinomial that has the x squared term with a number in front of it other than 1, you should ask yourself, can I factor out that number that's in front of the x squared? Can I factor out the a? Meaning, does the coefficient in front of the x squared term go into all of those? And in this case, it does. So we're going to factor out the 2. That means I'm going to divide each term by 2, just like we did, I think it was lesson 7-6 or 7-5. It's all a blur. 2x squared divided by 2 is x squared. 10x divided by 2 is 5x. And a negative 28 divided by negative 2 is negative 14. At this point, this looks exactly like 7-7, except there's that little 2 hanging out. Don't let the little 2 bug you. It can't go away. It has to stay there. It's like a little mosquito. But we can go ahead and factor that. That's the goal. I want to be able to write this in factored form, and when we get to quadratics, you will totally understand why we've been spending so much time on this. All right, so as you remember the factors of c to get the sum of the b, that's what we're looking for. So I see a negative 14, a positive 5. I know that when I multiply and I'm trying to get a negative, I need to have one number that's a negative, right? And then if I have to add those numbers and get a positive, the negative number needs to be smaller so I can get the positive as the higher digit. So 7 times 2 is 14, right? 7 plus negative 2 is a positive 5. The negative has to go with the 2 because if it went with the 7, I'd get the sum of a negative 5, and that's not going to work. I need a 5. So factored form, don't forget about your little mosquito 2, and we have a positive 7, and we have a negative 2, and that would be the factored form. Not too bad. All right, look at this next one, and you might be thinking, well, Mrs. Trombley, you're a little bit crazy because a is 1. The leading coefficient's 1, but do you see how that x has a little 3? And this says x squared? Yep. You can't have it cubed. That's a whole nother function altogether. So can I make this a 2 though? I know I could write on it with my pen, but mathematically, could I make it a 2? What could I factor out that would make this x squared? You guessed it, factor out your x. Wouldn't that be nice? We could just do that in real life. Just factor out your x. So there, this is real life. We're factoring out our x. There we go. Okay, x cubed divided by x. Yep, that's x squared. 7x squared divided by x is just 7x. And 10x divided by x is 10. And again, these are those laws of exponents. I'm cruising through because you've already been assessed on that, and you guys are awesome rock stars at it. So there we go. Now my leading coefficient here, the coefficient of the x squared term is 1. That means factor sum. So if the coefficient is 1, you can use factor sum. Kind of rhymes. Factors of c to get the sum of the b. And it's a plus plus. I like that. It means both my factors get to be positive. 5 times 2 is 10. 5 plus 2 is 7. So in the end, I'm not going to forget about that little x out there, even though we'd like to. I'm going to take x plus 5 and x plus 2 because those are both positive. And now we have just written that trinomial in factored form. Okay. Now sometimes you cannot factor out that coefficient. Look at this. I have 4x squared plus 13x plus 3. And these other terms here, the only term that's divisible by 4 is this first one, right? So I can't factor out the 4. That means we need another method to factoring this thing. Because doing a factor sum chart won't work. I promise. You could give it a shot. You can press pause and try to do a factor sum chart. It won't work for you. So method number 1 seems to be the go-to. If it's been a while since we've done something, we can always kind of guess and check our way around. So I don't want to dismiss it. I wouldn't recommend using this all the time because it can take a little bit longer, but we can guess and check it, all right? So if I have 4x squared plus 13x plus 3, and if I want you to write that in factored form, that means I want you to write this trinomial as the product of two binomials. Yes, and you know exactly what I mean because you all have done your vocabulary sheets and we're good. Okay, so again, I want to write this trinomial as the product of two binomials. See how it's a plus plus? I've seen the patterns and I have seen that when it's a plus plus, that means that this is a plus plus. And there's more, the patterns are actually listed out for you on the next sheet, so if you're forgetting those patterns, they'll be in your notes, don't worry. Okay, so now here we kind of mess around, we figure out what two binomials can I multiply together that will result in this. Well, mainly we're just going to look at the A and the C in this. A term, C term. So, to get 4x squared, there's a couple possibilities. I know that 2 times 2 is 4 and x times x is x squared. And I know that 4 times 1 is 4 and x times x is x squared. So let's start off with 2x. If you take 2x and multiply that by 2x, you'd get that 4x squared, right? Now when you multiply the last terms, that gives you the c, right? So the factors of 3, there's just 1 and 3. So let's try 1 and 3. So that's the guess. Now the check part means I'm going to FOIL this and see if I get the original equation. So 2x times 2x is 4x squared. 2x times 3 is 6x. 2x times 1 is 2x. And 1 times 3 is 3. And when you put 6x and 2x together, do you get 13x? Nope, so that's wrong. So I'm going to guess again. And this time, since I know I can't really change the factors of 3, but 4x has another set of factors of just 4 and 1, I'm going to change this to 4x and x. So now let's do the check part. 4 times x is 4x squared. 4x times 3 is 12x. 1 times x is x. 1 times 3 is 3. And this time, when you put the 12x and the 1x together, you get the 13x in the original trinomial, which means this is correct. Now you might be thinking, oh, that's not so bad. But think about it. What if this was like a 24 and this was a 32 and we had many factors other than just, well, it's either 4 times 1 or 2 times 2 and this is just 3 times 1. So the larger those digits get, the more difficult it is to use this method. But it is a method that will work. All right? Now I'm going to show you another method, another fun name. It's called the window method. And I think after you see this, you're going to think I made it up, because you know I like to make up weird and kooky things. But this is not something that I made up. This is a legitimate method that works. My husband uses this too with his algebra students. All right, it's called the window method because you're drawing kind of a little window, 4-boxed window. And this is how it works. Yes, I know this is the same exact equation that we just had. The idea isn't about the correct answer, it's more about the strategy right now. I'll give you other problems later on, don't you worry. Okay, so first thing you do is see if you can divide all of the terms by the coefficient of x squared. Nope, we can't. So step 1, write the first term in the upper left-hand corner and write the last term in the lower right corner. That's number 1. Step number 2 says, and this is kind of like a little doctored up factor sum chart, multiply the numbers of the first and last terms, find the factors that have the sum of the b. So when we make this kind of a factor sum chart, we're actually going to take the factors of a times c to get the sum of the b. And in actuality, that's what we were doing last time. It's just that last time in lesson 7-7, a was always 1, and 1 times c is c. So what we're doing now is, in our factor sum chart, it's the factors of a times c, so that would be 12, to get the sum of the b. So we still kind of get to use a factor sum chart here. Well, not kind of, we are. We're using a factor sum chart, but it's the factors of a times c. So this is a plus plus. I know that these are both going to be positive. 12 times 1 is 12, and 12 plus 1 is 13. Okay, so what are you supposed to do with these factors? It says fill in the other two sections of the window with the factors that we found, but make sure we include our variable. I see that we have an x squared here, right? But we need to have those x terms as well. So it doesn't matter which box you place which number in. I'll put my 12 up here with an x after it. And I'm not going to write 1x, I'm just going to write x. Because normally you won't see it with a 1. You'll just see x. And if I would have written 12x here and x there, it would have been fine. I'd get the same answer, no big deal. Okay, so that's our step 3. We fill in those 2 remaining boxes with the factors from a times c to get the sum of the b. Okay, now find the GCF of each column and row. So we're going to look over here and let's do the columns first. Doesn't really matter which one you do first, but I said column and row, so I'm going to go column then row because that's how I roll. 4x squared and x. What's the largest factor between those two? Well, they both have an x, so that's the largest factor there. Here I have 12x and 3. They both have 3 as a factor. They both don't have an x, so I can't include the x. There's the columns. Now let's do the rows. The largest digit that goes into 4 and 12 is 4. And they both have an x, right? At least one, so I can factor out one of those x's. Here, maybe you're thinking, I think our initial gut feeling is to say, oh, 0, because they don't have anything in common. They don't have 0 in common, because if 0 was a factor of either one of these, wouldn't there just be zeros written there? Yeah, 0 product property, remember? I know, we said it a lot in class and on the notes. So when you don't see a value that goes into them, it's really 1. 1 is a factor of x and of 3. 1 goes into everything. If it was 0, these would be 0. Now it's kind of cool, I don't know if these numbers look familiar to you, but do you remember that when we did the guess and check method, the answer was, the first binomial was 4x plus 1, and the other one was x plus 3? Yeah, this gives you the answer right there. So to write your answer, we just look at what's over here. I have a positive 4x and a positive 1, that means 4x plus 1. And I have a positive x and a positive 3, that means x plus 3. So those little GCFs that you just found, those give you your 2 binomials. I think that's awesome. I don't know if you think that's cool. Hopefully you're like, wow, that's awesome. Humor me, you know, whatever. Anyway, check it. 4x times x is 4x squared. Then I'd have a 12x and a 1x that would give me that 13 in the middle. And the 1 times 3 is 3. So you should always FOIL it out. You don't have to write it out, but FOIL it out in your head. It looked like I had like 3 of the same finger. That was weird. Anyway, I'll keep my hands down. I'm easily distracted. I'm in my puppy dog butterfly mode right now. Take 4 does that to you. But distribute it out. Make sure you get that trinomial. This is what I was talking about when I said the patterns that you see that are helpful to know. That's right here. So we're going to do this window method. There's one of them that's going to be a little bit strange. I saved it for last. But if you kind of know these patterns, you'll be less likely to get caught in one of the errors that can happen with this window method. So here's the pattern. Hopefully you've seen, these are all trinomials, right? In ax squared plus bx plus c form. When you're adding the trinomials, you always end up getting a plus plus. When you had minus plus, meaning a negative b and a positive c, you ended up getting minus minus. Reason being, when you add 2 negatives, you get negative, but at the end to get c, isn't it going to be this one times this one? Well, a negative times a negative is what gives you that positive. So minus plus is always going to be minus minus. And if you have plus then minus, you're going to have 1 of each. And if you have minus minus, you're going to have 1 of each. When you have plus minus, that's we talked about before, positive b and a negative c. To get the negative c, that means that the higher digit needs to be negative. And then right over, I'm sorry, to get this positive b, the higher digit needs to be positive. And to get a negative b, the higher digit needs to be negative. So we'll talk through these patterns, but kind of memorize it, maybe put a little star by that. Knowing how those patterns work will help you, especially if you're going to be using guess and check. Because I know some of you will still want to make that your go-to, which I'm okay with as long as you show me all your steps. But let's practice this window method, because I think the more we practice it, the more ingrained it will be. It's kind of a lot of steps, but if you get it down to a science, it won't be too bad. All right, step 1, look at the trinomial and see if you can factor out the a. I can't. A is 2, and both those other numbers are odd, so it won't work. That means we need to go to the window. So you're going to draw yourself a little window up in the corner, or wherever you can fit it. I think the corner is the best spot for it. And step 1, write the first term in the upper left corner and the last term in the bottom right-hand corner. To figure out the remaining boxes, I have to go to my factor sum. I want the factors of A times C. So 2 times 5 is 10, and I want to get the sum of the B. This is a plus plus, so I know I'm going to have 2 positive factors here. And this is a nice one, right? 10 times 1 is 10, 10 plus 1 is 11. Now I take the 2 factors that I found. I write them in the remaining boxes with the variable after them. I didn't write 1x because I don't need to. If you need to, go ahead, but you don't have to have that. Okay, now I want the GCF of all the rows and columns, rows, whichever. I'll start with rows this time, why not? So when you're looking at 2x squared and 10x, 2 goes into 2 and 10, and they both have at least one x, so we can factor out an x as well. With x and 5, this is one of those where, no, they both don't have x's, both don't have 5, but that means 1 does go into both of them. Now for the columns, 2x squared and x, there's not a number other than 1, but they both have at least one x. And 10 and 5, GCF of 5, 5 goes into both, but they both don't have an x, so we're done. Now I know this is a plus plus, and I should end up with a plus plus, so I have here 2x plus 1, and I have x plus 5. Because this is a positive 5, it means I would add. And that's it. But what you should do now is just double check real quick, do a little FOIL in your head. That's what I have to do when I get my highlights. So I'm going to get some highlights right now and do some FOIL in my head. 2x, probably, maybe your moms are laughing right now because you've had this experience. Or maybe you have had it yourself. So just remember to FOIL. It looks nice. 2x times x, 2x squared. Then I'd have a 10x and a 1x, which is 11x. And 1 times 5 is 5. And yay! It's right. This whole window method wasn't just some made-up random thing. It actually works. Let's try another one. This one is a minus minus. And if you look up at your patterns, this means I should end up getting one of each at the end. And you'll see how this kind of happens with the window. Alright. Can I factor out the 4? No. So I'm going to write 4x squared here. If you didn't keep change it, you may have written a 5 there, but that's not allowed. It's really a negative 5. So I'm going to keep change just to remind you of that. Okay. First and last term's all set. Now I want to take the factors of A times C. So 4 times negative 5 is negative 20. And I want to get the sum of B, which is negative 19. Now this is a little bit different because I have a negative and another negative. So think about this. If you're trying to get a negative when you multiply 2 numbers, it needs to have one negative, right? They both can't be negative, one of each. And if when I add them I need to get a negative result, that means the higher digit needs to be negative. So I know that 20 times 1 is 20, right? When I add these together, the one that I want to make negative needs to be the higher digit. Because negative 20 plus a positive 1 is negative 19. So negative 20 times 1 is negative 20. Negative 20 plus 1 is negative 19. Now I'm going to take those factors and write them up in here, put the little x after it. I know, everything's a song. I just can't help myself. All right, now we're going to find the GCFs. The GCF of 4x squared and negative 20x. Unless they're both negative, I don't want you to factor out a negative. So just look at the numbers 4 and 20. 4 goes into both, and they both have an x. With x into negative 5, they both don't have a negative. They both can be divided by 1, though. Factors would be 1. Here I have 4x squared and x. They have one x in common. And here, see how they're both negative? That's when I'm going to factor out a negative, when both of them are. And the number 5 goes into both 5 and 20, and they both don't have x's. All right. So now I see I have a positive 4x, a positive 1. That's going to mean 4x plus 1. And I have an x and a negative 5. That's going to mean x plus negative 5, or x minus 5. And remember we said if it's a minus minus, right above it, you should end up getting one of each. It doesn't matter what order. One of them should be plus, one of them should be minus. Now let's FOIL it to make sure it's right. 4x times x is 4x squared. I'd have negative 20x and a positive 1x. That would give me negative 19. And 1 times negative 5 is negative 5. It's right. All right, 2 left. 2 left. Originally, this lesson was 30 minutes, so be happy that I'm only at 20 minutes right now. It will not take another 10 to do these, I promise. Okay, this one is a plus minus. So that means I should get one of each at the end again. I can't factor out the 6, so I'm going to go to the window. I'm going to keep change that, so I make sure I put a negative 12 down there instead of a 12. So first term, upper left. Last term, lower right. For my factor sum, I want the factors of A times C to get the sum of. And remember, if there's not a number in front of the x, it really means there's a 1 there. So I want to know, what are the factors of negative 72 that when I add them together, I'd get a positive 1? Well, I know that when I have negative here and a positive here, one of these has to be negative, one of them has to be positive, and the higher one needs to be positive. So I know my multiplication facts. If you know your multiplication facts, and right now you're like, oh, sweet, 9 times 8 is 72. And if I want to get a positive 1 in the end, I'm going to make that 8 negative, because 9 plus negative 8 is positive 1. Take those factors, write them in the boxes. And now we're going to GCF. Find the GCF. So 6x squared and 9x. 3 goes into both of those. It's the largest digit that goes into both, and they both have x's. And here, they're both negative, right? So I can pull out the negative. I'm going to factor out the negative when they're both negative. And the largest number that goes into 8 and 12 is 4. Okay, now let's do the columns. 2 goes into 6 and 8. I'm not pulling out a negative because only one of them is negative. And they both have an x. And here, the largest number that goes into 9 and 12 would be 3, and they don't both have an x. All right, let's write it out. I have 3x and a negative 4, so that means 3x plus negative 4, or 3x minus 4. And I have a 2x and a positive 3, so 2x plus 3. FOIL it. 3x times 2x is 6x squared. And then I have a 9x and a negative 8x. Isn't 9 plus negative 8 1? There it is. Yep. And then negative 4 times 3 will be negative 12. All right, the last example. Whew, I know. We're almost there. The last example is a minus plus. And you saw in that other note sheet, when you have a minus plus, you're supposed to get a minus minus. When we do the window, it's not going to end up working like that. So put a little star by this one. This is where the window has a crack in it, and you just have to be careful. It's okay. So looking at that, I'm going to keep change it, and I'm going to see, can I divide each one of those terms by 3? Nope. So I can't factor out the a. That means go to the window. All right. First term, upper left-hand corner. Last term, lower right-hand corner. And then, to fill in these boxes, I need the factors of a times c, so 3 times 8 is 24, to get the sum of negative 14. So if you recall, when we have a positive 24 here and a negative 14 here, the only way to get a positive result here and a negative result here is to be multiplying 2 negative values, because 2 negatives when you multiply is a positive, 2 negatives when you add is a negative. I know those integer rules never ever go away. Seriously. All right, so I know that when I take 12 times 2, I can get 14. Right? So 12 times 2, that gives me 14. A negative multiplied by another negative will give me that positive, and then when I add them together, I'll get the negative. So I'm going to write negative 12 with an x there, and negative 2 with an x there. Don't forget the x. Otherwise, you're not going to end up having any x's at the end, and when you double distribute, it's not going to work when you FOIL it. Okay, so here we go, GCFs. Across here, they both don't have negatives, so I'm not going to factor out a negative, but 3 goes into 3 and 12, and they both have an x. Negative 2x and 8. 2 goes into both of those. They both don't have an x, so I can't factor it out, and they both don't have a negative, so I'm not going to factor that out either. Looking at this column, the 3 and the 2, nope, not other than 1, but both of those have an x, at least one, so I'm going to factor out the x. And here I have a negative 12 and an 8. I don't have 2 negatives, so I'm going to leave well enough alone. 4 goes into 8 and 12. Now here's where the problem happens, because it looks like it should be 3x plus 2 and x plus 4, but if you write this as a plus plus, there's no way to get that negative. So when you see in your factor sum chart, when you see that both factors are negative, That means at the end, even though it doesn't look like it's supposed to factor out, it should be minus minus. And knowing that right off the bat, whenever you see a minus plus, it's a minus minus, that'll help you out. So if you double check this, 3 times x is 3x squared. Then we have minus 12x minus 2x, which gives you minus 14x. And a negative times a negative is a positive. If you would have written plus plus, you would have had plus, and you'd have a positive 14x instead. So put a little star by that, and maybe make a little note to yourself. Minus plus in the beginning. I'm sorry, you should have just written minus plus, but this is, put the star by that. In the end, when you see that it's a minus plus trinomial, it should end up being a minus minus in the end. And you'll catch that error as long as you're always foiling at the end. All right, I'll see you tomorrow.